whatever. I was just like making sure this was like the right. I was thinking of it. I get connected before I see.
So mine's a little bit different. It's an exercise immunology project, focusing specifically on the role of macrophages and muscle regeneration following acute injury. So some brief background, kind of like how we went over in class. There is a brief overview of this presentation as I want to go over the M1 to M2 macrophage transition and muscle repair. And then we want to look at some data showing macrophage infiltration and cytokine changes post-injury. And then I want to briefly mention how some other immune cells contribute to regeneration as well.
But yes, you're right.
So some brief background, like we're thinking exercise immunology, like how does exercise impact the immune system and vice versa. And so just a quick reminder that our skeletal muscle has a remarkable ability to regenerate. And this is driven by some stem cells that are generated from our sarcolemma surrounding our muscle tissue. So we have a remarkable ability to regenerate this following acute injury. And this is a process that's tightly coordinated and it's driven mostly by macrophages. They're kind of the main orchestrators of this whole process. And in this orchestration, they have a pro-inflammatory phase and an anti-inflammatory phase that we covered in class. So the first figure I want to look at is to give an idea of what's going on post-injury. So in this study, they lacerated that gastrocnemius muscle in mice, and they just did an immunohistochemistry to look at the immune cell types that are going to be infiltrating that laceration. And so it's probably going to be hard for you guys to see in this first graph, but in this top one right here, the idea that I want to get across is that macrophages infiltrate and then peak at 7 days post-injury, and then they're maintained up until 3 weeks later, 21 days post. And then in this bottom figure here, we see neutrophils accumulate and peak at 1 day, and then they're dissipated and gone by 7 days. So neutrophils act early, and then macrophages a little bit later as they're orchestrating this regeneration process. And just out of curiosity, I'm curious, given this orchestration and the timeline of these neutrophils and macrophages coming in, there's not really like a right or wrong answer, but I'm just curious what you guys think the neutrophils and the macrophages might be doing.
I mean, it kind of represents just like, I don't want to say immune response, but kind of just to damage and dance. I feel like so there's more inflammation, kind of like initiating repair, which first they kind of have to, like I was saying with like M1s first, it's kind of like making sure, kind of like ensure, like containing the stuff, and then eventually, as they kind of morph away and go into M2, maybe it's like more repair, tissue repair, you know.
That's good. That's exactly right. Gavin, right? Yeah, that was good.
Yes, you're right.
So, kind of like Gavin had said, we have this distinct macrophage phenotype. And we have this M1 phase where it's pro-inflammatory, and this dominating early to kind of clear that debris, and inducing some of that inflammation. And then we have this M2 phase, which is largely anti-inflammatory, and then clearing that debris so that we can lay the groundwork for that muscle generation. And the timing and balance of this M1 to M2 transition is critical for effective muscle repair and recovery. And dysregulation leads to chronic inflammation or fibrosis. So this is a study that's looking at the in vivo impact of this M1 to M2 transition. And so prior to the study, there's been a lot of work done in vitro. And so we kind of have this, like, it's canonical, like, yeah, there is this M1 to M2 transition phase, and that was established in vitro. However, this one I think was done about maybe 5 years ago, and that's when they're starting to look at it in vivo. So they're looking at it in mice models, in vivo. And so, but they're comparing it to their in vitro comparisons. And so the figure here looks a little complicated, but hopefully we can break it down to make it simple. So the figure A, B, C, D, and E are comparing it to M1 phase in vitro. So all of these are comparing what they found in vivo to what they found in vitro. And so they're comparing this like canonical M1 phase that they found in vitro and the averages of those to then the in vivo. And so you can see at 3 days peak, you have this peak ILB or IL-1 beta and then TNF alpha, which is indicative of these pro-inflammatory cytokines. Similarly, so that's kind of what you would expect to see. However, it's maybe not as clear and cut and dry, given that it's like 3 days post. Similarly, in figures H, J, and K, or wait, first off, so F, G, H, I, J, K, these are all comparing them to the M2 phase. So we got this top one, and then these two are comparing it to the M1, and then these are comparing it to the M2. Because these are cytokines that are largely associated with these M2 phases, and that canonical like M2 phase and M1 phase, M1 and 2, respectively. So, in H, J, and K, those are the ones that we learned in class. Also at 3 days, we see a peak in TGF beta, which is interesting because that's anti-inflammatory. Similarly here in IL-10, right here, and in IL-10 secretions. These are just two different ways that they measured it. This is these are all reverse transcriptase PCRs, and then I think this is an ELISA, just I guess to double confirm it. And so this is interesting. So what this is telling us basically is like it's more of a mixed bag. Like it's more of a spectrum. It's not just cut and dry. And we see that because these peaks at 3 days with these pro-inflammatory cytokines, as well as these anti-inflammatory cytokines. Does that make sense? Yeah. So like in vitro, more cut and dry. In vivo, it's like, all right, a little bit more of a mixed bag, maybe not as like cut and dry as we thought it was. Just a quick recall question. Which phase would you predict shows higher IL-10 and TGF beta? M1 or M2?
So, I'm gonna guess that it's higher at M2, like trying to stop the immune response from chilling out a little bit.
Yes, good. Largely immunosuppressive. Nice. And then I'm curious too, just a recall question, or I guess more of an what we're gonna be talking about moving forward. What I'm curious what you guys might think would happen if there's no macrophages whatsoever. Just
I mean, would it maybe just like impair like tissue repair? I mean, there might be more to it, but
no, that's pretty much it. So in this study, they blocked macrophages' ability to infiltrate. And so what we see here in A, this is just healthy mice tissue. And then in B, this is in mice tissue where they put an antibody to block macrophage infiltration. D and this D images right here, just from right here. And then you can just see that there's a lot of fibrosis and yeah, collagen generation as opposed to this healthy muscle generation that we see in this mice model. So this is kind of just giving us a better idea, like, okay, these macrophages are not only sufficient, but they're also necessary for proper muscle regeneration. So bring it all together. Like you had talked about, the damage associated with medullary patterns increase whenever we have either like laceration or any sort of muscle injury. Then you have these tissue resident macrophages that are secreting cytokines, chemokines, and they're telling all these other neutrophils and other monocytes to come on in. And then we have this continuum, the spectrum of this M1 and M2 phase that we see in vivo. It's maybe not as cut and dry as we thought it was in vitro, but the M1 phase is largely associated with chemotaxis and this pro-inflammatory phase where you also have satellite cell activation and proliferation. And then you're also phagocytosing, a lot of damaged muscle fibers. And then you have the M2 phase, which is clearing out all the neutrophils and promoting satellite cell differentiation. And then you have proper healing of muscle tissue. And that's it. Any questions?
I gotta get it moving along, just to get all fine.